Today we will be looking at the Chapter 10 test video number 2 to explore differences in means. We have two companies that manufacture canned goods. Manufacturer A claims that manufacturer B adds more water to their canned vegetables. Let's start out by outlining our parameters for the problem. In order to prove their claim, manufacturer A takes a random sample of 30 cans, that's their sample size, from each company and measures the water content. Manufacturer A's sample of cans has an average or a mean of 4.5 ounces with a standard deviation of 0.63 ounces. Oopsies. And manufacturer B also has a sample size of 30, have an average of 5 ounces of water, and a standard deviation of 0.58 ounces. Test an appropriate hypothesis to see whether manufacturer A's claim is true. So here we have two independent samples, and we're working with means. So we are going to want to use a t-test for this to test an appropriate hypothesis to see whether manufacturer A's claim is true. So following our state plan do conclude method, we're going to state that we will conduct a two-sample t-test to see whether manufacturer A's claim that manufacturer B adds more water to their canned goods is true. We will conduct a two-sample t-test to see whether manufacturer A's claim that manufacturer B adds more water to their canned goods is true. Then we're going to want to move on to our plan step. So plan, we need to outline our hypotheses. So here we have our null and alternative hypotheses that need to be tested. So our H naught, or our null hypothesis, states that the average for the two manufacturers would be the same. And our alternative hypothesis, which is what manufacturer A is claiming, would be that manufacturer B adds more water, therefore the average for A is less than that of B. So now we have to make sure to check our conditions before we actually conduct our test. So random, it states in the problem up here, takes a random sample, so that's good. Then we have to check our normal conditions. And both samples, N1, you can call this A1, B is 2. N1 is greater than or equal to 30. Yes, it is equal to 30. And N2 is greater than or equal to 30. Yes, it is equal. And then independence. Yes, they are independent because they are two separate manufacturers. And also within each manufacturer, each of the cans is independent in this random sample. That's 10%. There are obviously more than 300 cans that are manufactured here. So now we are going to actually do our testing. So we're going to do, and this is where we do our 2-sample t-test. 2-sample t-test. And here we are going to set our alpha level to 0.05, which we will come back to later. So now we're going to open our TI Nspire, and we're going to want to go to Statistics, Stats Test, 2-sample t-test. After going through here, we're going to enter our data. So here we have the sample as 30. Yes, 30. Oh wait, that's N, my apologies. So X bar, or our average, so 4.5, and then 0.63 standard deviations, another sample size of 30, and then 5 for the mean, and standard deviation of 0.58. Now our alternative hypothesis was saying that the average for A was less than that of B, and then we are going to enter that. And as you can see here, after our results, we get a p-value of 0.0011. So p-value 0.0011. Now, when we look at this, what we're going to want to do is, using the p-value approach, we're going to look at this problem and see that, yes, this p-value here is less than our alpha level of 0.005. So thus, we are going to reject the null hypothesis. Is rejected as a result. So as we conclude this problem, we say that, therefore, we conclude that the null hypothesis is rejected, and thus there is in fact enough evidence to say that manufacturer A's claim that B adds more water is valid at the 0.05 significance level. So here we have each of the steps of the problem. After conducting our 2-sample t-test, we are able to conclude that our null hypothesis up here is rejected, and thus there's enough evidence to say that manufacturer A's claim that we were testing, that manufacturer B adds more water to their canned vegetables, is valid at the 0.05 significance level.